Right, thank you very much for having me. So this is sort of a talk in a few parts, and I'll go through how they work in a minute. The break stuff will be important later, and you'll see why. So you all really care about this stuff, so really quickly about me. I'm a senior software engineer at a company called Viva IT. We're the ones in orange hoodies if you've ever been to PHP Northwest, Symphony Live, South Coast, I've been there. You might have seen us there. If you do see us at any future events, come and say hey, we're quite a friendly bunch. On Twitter, at Brunty, or at PHPEM, I organise the PHP Midlands user group. We're having our unconference at the end of November, of which there's a ticket available. mfyu.co.uk or my email address, you don't care about that. So I do a number of things in my job and in my personal life as well. I'm a dungeon master for Dungeons and Dragons campaigns. The second time I've got a cheer for this, I'm so happy. I gave it in London and someone gave me a whoop. I'm like, I'm ending it there. I'm not doing this talk anymore. I'm going home, ending on a high. I mentor, I lead and I teach apprentices and junior developers, both in work, in the community. I run and organise PHP's Midlands and other events. I speak at a fair few user groups and conferences. I'm lucky in that I get time off work and paid travel to go to events if I need it. And the important part is I break production websites with incorrectly configured content security policies. So, as I mentioned, this is a talk in 3 parts. First, I'm going to cover cross-site scripting. Second, I'm going to cover what content security policies are and how they can help us. And then we're going to break some stuff. Not real stuff. I don't want to get, a deposit taken away. So we'll start with the scary stuff. We'll drop you in at the deep end and you'll see just how nasty it can be. So we had a brief coverage of cross-site scripting and in sort of HTML injection. But ultimately, what is it? It enables an attacker to inject client-side scripts onto non-malicious web pages. The important words are attacker and non-malicious. This is an attacker that you don't know on a website that you do know. This is a non-malicious website, lolcats.com, whatever it might be. In 2016, as one of the studies I was looking at, there was a 61% likelihood for a browser-based vulnerability to be found in a web application. And of those, 86 were cross-site scripting related. So that means that just over 52% of all web vulnerabilities are cross-site scripting based. It's quite a lot when you think of the number of websites there are on the internet and the number of things that are found. That's a fairly large number. Link to the study is there. All the links through the slides will be available at the end of the talk if you want. So, what can we do with cross-site scripting? I mean, most people, it's just a joke vulnerability, right? It's stick some cats on a web page, alert poop emoji to your friends, rickroll someone, self-retweeting tweet from Twitter. Who encountered that one? TweetDeck had a vulnerability. Someone put a script in a tweet. If you saw the tweet on your timeline, it retweeted itself to everyone on your timeline, and their timeline, and their timeline, and there you go. Who heard of the Sammy worm? Back in the days of MySpace. That was a worm where they put a script on their MySpace page, back when MySpace was still relevant, and if you visited that page, it added him as a friend to you, and then took that script and put it on your profile page as well. And then anyone who visited your profile page added him as a friend and got the script added to them. It spread to like 1 million users in less than 24 hours, and he actually served probation time and wasn't allowed near computers for years because of that. So it's not quite a joke vulnerability. You can make modifications to the DOM. Replace a form action to submit login details to your site instead of theirs, as demonstrated earlier. Use XML HTTP requests in the background to go and fetch additional resources you might need to perform an attack. You can access HTML5 APIs, webcam, microphone, geolocation. You can steal cookies, and therefore steal session cookies. This one's quite a scary one, because if you've ever used a website that has these sorts of bits of functionality on them, you might have seen an option like this. Always allow on this website. If you haven't seen, I have a little slider over the webcam on my laptop. Legit, come and have a look, it's fine. But that's kind of scary if that site gets breached. You're sat there in your pants on the sofa and suddenly someone's taking pictures of you. But what makes this really, really, really not a joke vulnerability? Back in 2008, hackers assaulted epilepsy patients via a website. There was an epilepsy support forum that was vulnerable to cross-site scripting. They injected scripts that would post hundreds and hundreds of seemingly legitimate-looking forum posts that when you clicked on them would pop up full-screen flashing colors, patterns, sounds, and images, causing real people to have seizures sat at their computer. Photosensitive epilepsy.
No, why?
Why did they do it? They're crap. People suck. Why do people do anything? It's horrible to think of, but someone out there will do it. So this really isn't a joke. Despite being, oh, it's cross-site scripting, put some cats in, alert poop emoji, you can actually do some real damage. And when you consider the Internet of Things and eventually potentially being able to escape out of browsers, containers help it, but if you could escape out of a browser and suddenly you're on a local network with an Internet of Things connected pacemaker or whatever it might be, starts to get a little bit more serious. So, there's a number of different types of cross-site scripting. Type 1 is known as persistent or stored cross-site scripting. And it occurs when input is stored from a user, profile pictures in a database. But it could also be through a HTML5 API in the browser. HTML5 gives us local storage, which allows us to store values in a browser that don't ever touch the server. But it's still stored data that could be read by the site and output somewhere. This is a really good one. Whois was a website that got rickrolled by a TXT record on a website because they put in a TXT record that was an iframe to the Rick Astley video, and Whois was just reading that from the records and dumping it out on the page. So it wasn't even stored by them, it was stored by someone else. Don't trust your input, even if it comes from someone else's API. And that really happened. It's been fixed now, but it was a thing. Type 2 is known as reflected, non-persistent. And it occurs when user input provided is sent back to the user without being stored on the server. So it could be in an error message, it could be in a search string, it could be in a form value that's repopulated. It's not necessarily stored anywhere. You send a request, server does something and sends data back to you that you sent to it as part of its response. It's not stored, and it might actually not even touch the server, so you might not ever know about it. And that's covered by the next type, which is DOM-based cross-site scripting, type 0. But this is where the entire flow of the attack takes place within a browser. So you won't even have server logs to work out that this is happening. For example, if you've got JavaScript that's executing, taking some input, using document.write and outputting stuff, potentially you're vulnerable to this sort of thing. There's a fourth type, known as self-cross-site scripting, but some people don't consider it a true form because it's social engineering based. Effectively, you have to get the user to execute code for you, but you can do so by the console. You know, you ask someone, hey, go onto facebook.com, put in this code on the console, you'll get access to your friends' messages. We all love that idea. And because you're doing it via a console in a browser, it can't necessarily be protected against because the console has an elevated level of privilege and it can do things that other things can't. Some people don't consider it a true form of cross-site scripting because you're asking the user to do something. Server-side equivalent would be talking to a sysadmin and say, hey, can you just run this command in your server for me? Technically, yeah, maybe. Just as a note, if you've ever gone to who's gone to visit the console on Facebook before? You'll have seen a message like this. So if you go onto Facebook and open up the console, it will say, stop! Big red letters, we know this is important. This is a browser feature intended for developers. If someone tells you to do something, you'll lose access to your account. Don't do this. So you can put that sort of message into the console to say, hey, don't trust your mate Dave from the pub who's telling you to enter this code. So there's some potentially damaging things we can do with cross-site scripting, but we need to fight back. We need to defend against these sort of hackers, and we can tell they're a hacker because 1, they have a hood up, 2, hunched stance, 3, claw-like fingers, okay? So, oh, and he's also a member of Hydra, just in case, that's not. It's actually my friend Froggy. He's fine with this. I got his permission to use this picture. Hey, can I use this picture in my talk? Maybe mock you a little bit. He's like, yeah, it's okay. You can't see my face. It's fine. Right. So, what is a content security policy? Basically, it's a HTTP response header. It helps reduce cross-site scripting risks. No, I don't say eliminate cross-site scripting vulnerabilities, because that doesn't exist. There's no silver bullet. We're not fighting werewolves here. It's to reduce cross-site scripting risks that you may have on your site. It's another tool in the tool belt to help you fight back against vulnerabilities, against hackers, people who want to do bad things. There is no silver bullet with security. It's a constant cat and mouse game. You're chasing them, they're getting away. It's just the way it is. And it works by declaring what resources the browser is allowed to load when a page loads. By default, browsers are really, really, really stupid. You tell it to load a script and it'll go, cool, I'll do that. Let me just go and fetch mybadsite.com/superhack.js and I'll execute that code for you because you wanted it. Hey server, you've told me to do this, I'm going to do it. And a content security policy, you add a list of things that it's allowed to do along with the content you send back. So ideally, you say, okay, don't allow anything that isn't on these sites, or only allowed these things. It's a browser thing, so it requires browser support. And if you ask me if it works in IE6, I'm sorry, it doesn't. I've been asked that question time and time again. And if you have to deal with IE6 still, I'm so sorry. You have my full sympathy. I will buy you a bar at the drink, and we'll get through this, okay? Browser support used to be a little bit patchy. It's better now, but it's still not perfect. There's a few different levels. There's level 1, level 2. They just support different directives. It used to be you had to use the whole X- notation in the header. That's gone now because X- notation in headers is kind of stupid, and they said just get rid of it. But it's actually under a content-security-policy header. Chrome supported it for ages. Firefox supported it for ages. IE, Edge, recently. But there's no harm in putting it in. If a browser doesn't support it, it will just ignore it. It's just a header. It doesn't do anything. So we can protect a number of different things with a cross-site, with a content security policy. We have something called a default source, which is like a fallback. If you don't specify something more specific, it will go, you haven't told me what to load for an image, so I'm going to fall back to my default. And if it doesn't match that, you're not having it. We can protect scripts. So JavaScript. We can say, hey, don't load mybadsite.com/superhack.js. I'm only allowing stuff from myself and Google Analytics, for example, or New Relic's JavaScript file that it might include. We can protect styles. Because while styles might not be considered that bad of a thing, you can rewrite an entire page in CSS. You can do some amazing things. And include external resources with CSS, and now you're executing code from another person's server. You can protect images as well. And a really cool one, which kind of ties in quite nicely with the demo earlier, you can protect form actions. So you can say, don't submit a form to any website other than me. So if they do manage to get in and replace your login form with one that points to their own site, browser won't do anything. It'll just go, nah, I'm not going to allow it. You've not told me to load mybadsite.com, so you're not having it. It's not allowed. And quite a nice little extra that you can do with something like this is, who's had trouble going from HTTP to HTTPS because they run, say, a content management system and the users put in loads of images and links and things that don't load over HTTPS, and you get mixed content warnings, and it's all horrendous. You can upgrade insecure requests with a content security policy. So if the browser detects that an image is being loaded over HTTP instead of HTTPS, it will try and upgrade that instead and request it over HTTPS. Now, it still needs to be available over HTTPS. It doesn't just break the encryption of the internet. It still has to be available over a secure connection, but it will try and get it over a secure connection if it can. There is a full reference online, contentsecuritypolicy.com, or the Mozilla Developer Network is one of the best resources for front-end and browser stuff these days. If you're still using W3 Schools, stop it right now. There is a Chrome extension that will remove W3 Schools results from Google searches, and it's amazing. Whenever you type anything for front-end stuff, add to it MDN, and you'll get the Mozilla Developer Network, and it's just phenomenal. It's one of the go-to resources. So if nothing else, use that, not W3 Schools. You'll be good. So what does a directive look like? How do we protect something? What do we do with this? You've got these images and default sources, that kind of thing. What do you do with them? If you, in your content security policy, specified an image source of star, it will allow any URL except data, blob, and file system schemes. So if you've got, base64 encoded SVGs directly in line under a data scheme, that wouldn't be allowed. Blob and file system, same thing. But otherwise, allow an image from any URL. If we have something like object source none, would just block it outright. Don't load these from any source, regardless of whether it's me or someone else. I don't trust anyone, not even myself. You could have script source self, which allows loading from the same scheme, host, and port as the page has loaded on. So that says, as long as the host is the same, the scheme is the same, HTTP versus HTTPS, whatever it might be, and the ports are the same, I'm good with this, you can load it. Who here has JavaScript written inline in their templates? Script block, load a JavaScript, end script block, and executes onwards. Who likes having that? Who has to have it because some silly CMS requirement you need to output dynamic stuff based on that? Yeah. You can load that with a content security policy. It's allowed. You can load unsafe inline. And it allows the use of inline source elements such as style, attribute, on-click events, script tag bodies, that kind of thing. Don't use it. There's a kind of a keyword here. If we could just get rid of these two letters, it'd be fine. But we can't. There is a way around this. So if you've got a script tag that executes inline within one of your templates, and you can't extract that to an external resource to include because whatever reason, they were mentioned earlier, you can use a cryptographic nonce, which is a number used once. And in the header, you specify nonce dash, and don't put the $random in. Substitute that for random string. Despite what they might tell you, $random is not a cryptographically secure number. And you use script nonce, and then you include that nonce within a nonce attribute on your script. And what that does is, because in theory, the only thing that should be set in those headers is a trusted part of your application. They shouldn't be coming from database content, for example. The browser says, OK, if this random number comes back and matches what's in here, I can trust that this script tag has come from a trusted resource. Yes?
Sorry, for a live question.
Yeah.
Do you have the same nonce all the way throughout the page?
Yes, you don't. It's nonce once per request, not once per resource. Yeah. And in theory, if anything could inject this script, if you could try and inject a script into someone's website, at that point you shouldn't have the nonce because it's generated in an application. You're probably not. This data coming from the database isn't being parsed by your templating engine in order to do that. And if it is, then there's probably bigger issues. But in theory, the idea is that that's not available to whoever's managed to put that script into your database, for example. But yeah. A content security policy looks like this. It's just a header, and then you specify a long string of stuff. So in this example, default source of none. By default, no, I'm not trusting myself. I don't trust you, I don't trust me. I'm going to hide in a little box and say no to the outside world. But that's not going to get us much. We're not going to be able to do a lot with that information. So we're going to say, I trust any scripts that come from myself. We all trust Google, right? So we're going to trust Google. And I've got a nonce here of random123. Again, no. Purposes of example, see the difference. And that's how I'm going to load my scripts. My style comes from myself, because I don't need to load CSS from anywhere other than myself. Image source, I'm not going to allow hot linking of pictures from lolcats.com. It's only me that's doing this. I want to upgrade in secure requests, because this is a CMS website, and my user that's using the CMS has put loads of images in line WYSIWYG editors in HTTP form. And I'm only going to allow forms to be submitted to myself as well. So this is confession time, and we'll take a seat. Hi, my name's Matt. I broke production. I'm very sorry. This talk is a part of atoning for my sins. And hopefully this next part of the talk is going to be, don't do what I did. I was an idiot. I'm teaching you how to avoid doing a Matt. That's not the right thing to do. I broke production. Things went badly. Clients phoned up. Matt, the website's broken. I'm really sorry. I'll try and fix it. Yeah, but you broke it. Yeah, I know. I'm on the phone with you. Let me fix it and I'll get back. The longer I'm on the phone, the longer it takes me to fix it. I'm very sorry. Repeat for 5 minutes, and then I put the phone down on them and fix what I broke. So, First thing that happened to me was I didn't know what was going wrong. I deployed this thinking I knew it all, obviously. I deployed this content security policy to a website, and I didn't know what was going wrong. They just phoned up, as clients do, it's broken. Yeah, it's really broken. Can you fix it? The problem was, to me, it looked okay. It turns out that because it's a browser-based thing, it was affecting their browser differently to mine, and they had some plugins that were broken and doing additional things, and I couldn't see that. So, you know, works on my machine. Can't help you with that one, sorry. But just to be safe, I disabled the content security policy, just, you know, to make sure that they were, hey, I fixed it, it's good. The problem was there that I didn't know what was going wrong. I didn't know what was happening. And that's because I'd completely skipped over this rather important part of the CSP documentation about reporting. Reporting is another directive that allows you to specify a URL. And when a policy failure occurs, the browser goes, hey, bad thing, and sends a payload to that URL. Which is great, because now you've got reporting. You can tell what went wrong. Works on my machine, that isn't an excuse anymore. Damn. The JSON payload looks fairly simple. CSP report tells you where it blocked, all the various different bits of information you might need. This one used to be for LastPass, because the way their extension worked was they'd inject scripts onto the page to get things working. And then my CSP went, no. I ended up in a discussion with the LastPass devs, and they kind of went, sorry. So that was kind of handy when I discovered this. And I thought, I'm going to have to write something to capture JSON, store it somewhere. I need to report on this. I need to put it somewhere so that I can work out what's going on. And then I discovered a website that someone I'd been following for a while, a guy called Scott Helm, had written, called reporturi.io. So what this does is you sign up for an account. You can pay for it, but it's also free. So if you do sign up under your company, give them a few quid a month as a part of the subscription, because you don't want to build this. But effectively, it's a website that gives you a URL to submit to. So you put that in your policy, and when a violation occurs, it sends a request to report URI with the payload, and says, right, store it, and report URI stores it away. Later on, you get nice reporting, you get filters, you can say, hey, what's Safari done, and what's Chrome done? But you can also do some kind of bad things with this. Not purposely. Who's heard of or used Envato before? It's like an Alexa top 1,000 site. It's pretty big. It sells a lot of WordPress themes and other bits and pieces. They get lots of requests, like lots of requests. And they deployed a badly configured content security policy that was reporting to reporturi.io. And at peak load, Scott Helm said that he had 4 load balancers, each with 45,000 requests a second going through them, before he had to terminate it and go, I'm very sorry, because DigitalOcean is shouting at me. Security policies as a distributed denial of service method. Maybe? Oh, the hunters become the hunted. Report URI looks a lot like this. You can see, here's the directive that was violated, here's what was blocked. You can get the full policy if you want to, and you can see the browsers that have done the various things to block it. You can filter this, you can view graphs of it, you can get it by date, all that sort of stuff. It's quite nice. I won't go into detail. Go and use it if you decide to after this talk. Now, this is cool, because now I know what's going wrong, but the site's still broken. The browser's telling me, hey, this is broken, but the site's still broken. And I now know what's causing me problems, and that can make it a little bit more stressful, because I know the problem. Give me time to fix it. And then I discovered report-only mode. And this is even more wonderful. What you can do with this is specify a policy that only reports violations, doesn't enact them. So if something bad happens, it doesn't actually cause the website to break. It just says, hey, you might want to be aware that this thing tried to happen. And then it doesn't actually do anything with it, which is really nice because you can kind of actually test stuff in live before you put it, you know, into an enacted state. Because whilst you can test content security policies in tests and CI suites and whatnot, you can't test for every possible user on your site doing every possible action, because I don't want to test that. And the way it works is pretty much the same as a normal content security policy. You just say it's report only. And then you put in your policy here somewhere, and then you say report URI, your app URI here, and does the same thing as before. but it allows you to trial stuff before you enforce it. Word of warning, there will be noise. When you first set this up, there will be lots and lots of noise because you'll get it wrong. I'm not putting you down as developers that. I got it wrong. The way to work through this is to do it iteratively. Don't try and get everything working first time. Put something in place, make sure it works. If you've got a lot of things that are broken, fix those, implement a new one, report only, until you get to the point where you're comfortable putting this into an enforced mode, and then enforce it and go from there. So, I'm going to give you a few tips on how to make dealing with the content security policy a little bit easier. Have an easy and quick way to disable the content security policy in production if you need to. Thankfully, our deployment process is kind of quick, so I just deployed the previous version and everything was fine. Fix went out in like 2 minutes, once I'd got off the phone with them, because, you know. Better yet, don't disable it. Have a way to switch it from enforced to report only, so you can still continue getting those reports on what's going wrong. And I'd really highly recommend adding the content security policy at an application level. You can add it at a virtual host config level if you want to. But that means in order to roll out any new changes to it, you have to reload the server config, which isn't generally a problem, but it's probably a bit more hassle than just deploying your application again if you've got a decent deployment setup. And also, if you want to do cryptographic nonces in it, it's kind of, you have to do it at an application level. You can do it in web server config, but you don't want to. I've seen the configuration for it, and it's like reading hieroglyphics. It's not going to happen. So, with cryptographic nonces, don't generate multiple nonces in the same request, but do generate one on every new request. Because if the cryptographic nonce is the same on every single request, I'll just inspect, view the network tab. Oh, look, there it is. I'll inject the script with that nonce already in place, and hey, look, you're vulnerable again. If you're using a templating engine, such as Twig or whatever else you might be using, you can add variables to Twig as a global, so you don't have to add it on every single template. It will just be available to every single template for you. So do that, and then developers can't complain, yeah, I was going to put it in, but then I have to put it in the controller and add it to my view layer. It's just, that's hassle. So do that, and then as soon as they say that, no. You do what you're told. And if you need to, write a helper in your templating language of choice to output a script tag with a cryptographic nonce already in it, as part of your templating engine. Then you don't have developers complaining about this as well. So if you do these two things and developers are still complaining, then have a talk with them. Because you've removed a lot of barriers to development with this. So we're going to break some stuff now, and if the demo doesn't work, then I can just say, it's fine, it's meant to be broken. So give me just a second. Okay, 10 points if you know where the company's from. It's from the greatest movie of all time. No? Okay. It's Hackers. Oh, yeah, now you get it, right? Who here hasn't seen Hackers? Homework. Okay. Go and watch Hackers. So we are a rather large development team that has produced a rather small website for Ellingson Mineral Company. And there's a number of key features that we've been told to build into this website. So we have a homepage. It gives us lots of business blurb. We don't want to boil the ocean yet. High turnaround rate, critical mass. These are all important words that business needs to know. We have a page on our website for the Gibson, which is our supercomputer that's running in, the mainframe running in the basement where the nerds are. And the thing we need to know about this, it's absolutely crucial for marketing to make this aware, to make the users aware of this. This page is totally secure. Okay? If we don't tell the users this, they're never going to know that they can trust us. Okay? So we do that via an obnoxious pop-up, because then they can't ignore it. And now they trust us with all their data. Cool. This is our Gibson. It's lights, lines, holographic boxes. We're serious business with this, okay? We're not only going into computing, this is like augmented reality levels of awesome, okay? And then the final place is we have a load of place to put our garbage files. You want a notepad just to put stuff in. And again, we know files are secured. That's important so that we know that we can put stuff in here. And we've got secure files. So that's the website we've built. Those are the features we've got in place. Now, an attacker comes along, and you know I'm an attacker. I have a hood. I have an arched back, claw-like fingers, okay? So an attacker comes along, and they look at this website, and they say, there's a number of things that I think I might be able to do here. Based on the talk from Craig there, it was you pick out one little area, and you go for that, and that's how you work out what's going to happen. Sorry, the hood's annoying me now. And we notice there's a couple of things here. One, files secured, and files secured. And we look at that and we say, okay, maybe, okay, files are not secured because I can now control the content on the page. And I look at this and go, that's a reflected cross-site scripting vulnerability, potentially. So the next thing I do is I look at this website and I say, okay, no. Live typing. Hack the planet! Okay, what we've worked out from this is they're not escaping their output. They've got a templating engine or whatever they're doing that doesn't sanitize or validate or do anything with the output. It doesn't escape it. It just goes, yeah, I'll do whatever you told me to. So that's quite cool. I'm not going to go through full examples, but with this, we can now execute whatever code we want to on this page and send it to a user. So that's step one. And then we look at this and we say, I'll put some content in the form, and I'll update the note. And I can see that the content is returned to us on the page. And the next time I come along to this web page and I view it, the content is still there. So I've got a storage engine here that I can interact with. So, similar to the last example. Actually, should we see if poop emoji will work? Yay! The poop emoji! Cool. So now we've got a script that runs, and if I go back to the page, it runs, and if I go back to the page, I've got endless poop emojis. This is amazing. So, now they're also vulnerable to stored cross-site scripting attacks. So we get told this. Marketing team phones us up, Matt, site's been hacked. Fix it, or don't come into work tomorrow. Crap. Okay. So they don't like the fact that our professional image is tarnished by poop emojis everywhere. So we say, aha, okay. I heard about this thing called a content security policy, right? Maybe I can fix the problems I'm having with one of those. Seems like it might work. So this is effectively a very simple application I've got written in Slim. There's a number of things that, there's a large comment here. Browsers these days implement a lot of built-in protections for cross-site scripting attacks. They will try and block script stuff that comes into a request. If it sees it in a request, it will go, I'm just going to ignore it and kick it back. There's a way to disable this by setting a header with a middleware that I've got here. Don't do that. Because if you do that on your real website, you need to understand the implications. I'm doing this for demonstration purposes. It's for your benefit. Do as I say, not as I do, okay? But that effectively sets a header that disables the XSS protection middleware in a browser. But in order to show you a vulnerable site, I need to do that. So now we add a middleware to our site. And who's familiar with middlewares? For those of you that aren't familiar with them, effectively they're just small little blocks of code that can do things with requests and responses in an application. So when a request comes into your application, you can have a number of functions execute before it hits your application. And then when it leaves your application, you can have a number that on the way out as well. So this one adds a header to a response, when it comes into our application. I can show you this, because here I call a with added header method on our header and replace it with a content security policy that we're about to configure and fix the problems of our website. So, by default, we can fix this. We go, right, I'll beat the hackers. I'll show them. They're not going to hack our website. I don't see any poop emojis. I don't see much of anything else as well, though. So that's a bit of a problem. So we look at this and we go, yeah, their marketing's not going to be happy. I mean, for one, there's no logo. That's the most important thing. They're not going to like the fact that the company isn't represented properly. So we should probably fix that. So we say, oh, okay. So we say, I'm going to allow images from myself, okay? I don't trust anyone else with images, but I trust myself with images. We come back, we've got the company logo in place. Step one to them being happy, company logo's in place. With that, we can now navigate around the site. Everything's there. Homepage image is working. Gibson image is working. Cool. So we then look at it and we go, our styles aren't quite working properly. They're not going to work either. So we'll load styles from myself as well, because we want to be able to have styles working. So we'll put those back in place so that we can get the site looking a bit better. That's cool. We fixed it, right? We've got the home page works, we've got images, we've got styles, my garbage files page, it's no hack. I load the Gibson page, and the marketing team's not happy because how do the users know if we're secure if we don't put an obnoxious pop-up in their face telling them that we're secure? So we go, okay, fine, I can fix this. And when we look at our code base, we see that in the Gibson file, we have a script tag that says this page is totally secure. Okay, that's how they know that we're good. So we say, okay, I need to fix this. It's an inline script tag, so I know there's this thing. And I say, right, allow scripts of unsafe inline to run. And we say, cool, excellent. Marketing are happy, the page is secured. The home page works as we'd expect it to. And, oh no, that's a problem. Because they don't like those poop emojis. They're not going to like that. For our purposes, we can't extract this into an external resource, so we need to look at additional options. So, I'm going to just undo so it's all here. What we're going to do instead is in my script source, I'm going to add here, I've just got a placeholder, it will just replace this with a cryptographic nonce that I generate on each request. And I say add a nonce to the header that you're sending back out. In my template, that's not going to work because I've stopped the hackers. That's cool. They're no longer exploiting us. But that script isn't executing because the nonce doesn't match. If we look in the browser, in the console, oh, I've also put in the Facebook approach because my friend told me to do it, and then the next thing I know, my account was hacked, and Dave down the pub, I thought I could trust him, but maybe not. But you'll see it tells me that it refuses to execute the inline script because it violated a policy. So in order for this to work, in my template, I'm going to add in my cryptographic nonce. I've made this available to every template I'm rendering so that, again, there's no excuse for me not to put this in. So now when I go back to my browser, I can see the page is totally secure. Marketing are happy. The home page loads, images, all working correctly. Page is secure, and no more poop emoji. I think I can deploy this now. So, that's a really condensed version of what happened. I might have deployed between each phase when I was working on it because I was an idiot. But you don't have that, you have me telling you to not do what I did, so that works. So, if you want to follow anyone, go follow Scott Helm on Twitter. He really that's not me. I'm Matt, that's Scott, he's a different person. He really knows this stuff with content security policies. He wrote Report URI to deal with this. He's got another website, securityheaders.io, that gives you a nice little green box and an A+ for setting all the relevant security headers, such as the new referrer headers, security policy stuff, strict transport security, all the various things you can do to protect your site. You get a nice little, hey, look, A+, good job. All the links I've included within this talk are here. The demo site is on GitHub if you want to go and take a look at it. Feel free. Just really quickly, the reason that the demo site was vulnerable to this was because on the garbage files page, I'm doing this in Twig. I'm saying raw output. Don't do this. Twig has escaping, but if you need to output raw data, you can pipe it into raw. In reality, don't do this. Again, I'm doing this to show you, do as I say, not as I do. This is just to demonstrate the problems of just dumping raw output onto your page. If I didn't have raw, none of that stuff would have executed before because it would be escaped into HTML entities and it wouldn't be a problem. Thank you very much for listening to me prattle on, and hopefully you're not going to go and break websites, or if you do, send me a tweet. I'd like to hear that you're in the same position as I was. Feedback there if you want to leave it. Brunty, PHPM, website, don't care. Anybody got any questions?
Use the self keyword, which basically says let any resource from come from that. One of the things I've tried doing is just not actually using self, but the current domain name and then a folder, because you might have a folder called the JavaScript file, whereas you may have a folder or server uploaded files, which is usually JavaScript. Would you go down that route yourself, or a different way?
I would try and segregate stuff off as much as possible. So with the example earlier about like Cloudflare, for example, if you're serving image assets and whatnot through Cloudflare, I would set up a subdomain for like media.yourwebsite and have that run through Cloudflare and everything else not. So the other traffic doesn't go through Cloudflare, they can't decrypt it, but they can still serve you images. It helps to reduce that a little bit. I would probably put images on this place, and then if you try and load an image from anywhere that isn't images.mysite.com, it's probably not come from a legitimate source and it would be blocked. Same with potentially styles, media, whatever you need to do, I would generally potentially try and do that, and it would look for that. I just use self there for speed, basically. Yeah. So there's, yes?
So when it does the reporting, it sends the data to a URL, does it just try and just do it once and then quickly time out, or does it do something stupid like keep trying to refresh?
I believe it just does it once. I don't know off the top of my head, actually. But generally, I don't think a browser would sit there and go, try again, try again, try again. It's just, the reporting, it's kind of, it's not a critical aspect of it, it's a nice addition to the policy. I don't think browsers would go too crazy over trying to do multiple things with it. The browser sends the post request, not your website sends the request, it's the browser itself. Again, so that it's just one of those, you just set it and forget it, basically. Yes?
Can it cover fonts? Can it cover fonts?
Yes, absolutely. The full directive on the Content Security Policy website lists everything. Fonts, sandboxes, iframes, objects, everything you can think of is pretty much covered. Fonts are covered. If you load fonts in via CSS, if you allow styles to load that, they won't load those by default as an extension. You'd have to specify the fonts as well. But there are new things with, like there's a, I can't remember what it was called, it's Base URI allows you to do that sort of stuff. There's also the new, what's it called? I can't remember off the top of my head. The other header that allows you to trust anything that thing includes. I can't remember what it's called again. Yeah. There's a thing that allows you to say, if that site can load it, I'll trust them as well. So you might load discuss comments on your page, for example. If you don't allow everything else that discuss allows in its thing, the content security policy will block it. So it will load the discuss script, but won't load images or avatars or their ad tracking networks, which is kind of nice because you can block ad tracking networks on discuss with content security policies. But there's a new header that's coming, a new directive that allows you to say, I trust them, therefore I trust whatever they're doing, so load everything else, and you can do that. So that would help with the CSS font stuff, but at the minute you can specify a font directive as well and control all of that as well. There's a big long list, far too much to cover in a talk, but yeah, they're totally possible. Yes?
I take it that in browsers that don't support CSP, it just...
Nothing happens, just ignores it.
Are there any halfway browsers that support it?
There's partial support in some. There's various directives that exist in version 1 and version 2 that there's a little bit of crossover. The browser will try and support the latest version it's got. The way I see it is that just put stuff in, and if a browser doesn't support it, it will ignore it. The counter argument that I've had to that is, well, then why would I bother if it doesn't protect everyone? It's like, well, in that case, just don't do anything. But the whole point of this isn't that it fixes everything. It's another step to help fix stuff. Hence, there's no silver bullet. There's no magic answer to security. It's just another thing to do to protect against 80% of the scripts that are going to run against your website. Because the reason I cover the cross-site scripting stuff is because it's such a big vulnerability. That's the biggest thing that a content security policy protects against. So it's quite a big win. You can do not much work, but get quite a big win when you're working with something like this. And that's not to say don't escape your output, don't sanitize your input properly, do all of that stuff that you were doing. This is just another thing to help if you missed anything. Yeah. Yes, sorry, come to you a second. Yes.
Can it be fake?
let's say somebody else allow this domain to provide content. If you fake the domain, if you think, then I'm just guessing, fake or a website allowed or giving this content, so that's allowed within my security policy. And I manage somehow sending a request as they
thinks it's talking to the same domain, but it's talking to your server instead of theirs. Do you mean? The browser doesn't look at IP address, so it would still pull that content. But in order to do that, there's probably other issues further along the line that a content security policy is not concerned with. You've managed to alter network traffic or get something in place that's changing requests. So that's kind of not the thing that a content security policy would protect against. Yes.
Kind of on the same note, you looked at how this is affected by service workers, which act as a proxy and can alter HTTP headers, JavaScript.
I haven't. I'm not a huge doer of front-end work with service workers. But I believe service workers can be included as part of the policy. I believe there's a directive for them, so that might control them.
You can alter HTTP headers,
yeah.
requests as they come in and out. So you can inject somebody, a service worker into somebody's page and then remove the content security policy.
But then there's possibilities you've got to be able to get the service worker onto the page, which the policy should block in the first place. One of the questions I often get is, could I use JavaScript to get the nonce and add a script in with the nonce in? I'm like, you could, but then you've got to get the JavaScript in the first place, which is blocked by the policy. So you can't. That first part of the loop doesn't even work. So you can't then go round and round. You can, if you still got them to execute a cross-site scripting attack in the console, you tell them to go on and do something, it will totally work because the console can do whatever it wants. It won't load things that violate the CSP. But you can write a script that will add a script into the page with the right nonce because it can search through it and then execute that script. But if it tried to then go and fetch an additional script from mybadsite.com, if you haven't whitelisted that, then it would be like, I'm not going to load that because you haven't asked for it. That's kind of the difference there. Yes?
Can it block console or plugins or anything like that?
Plugins have an elevated level of privilege a lot now. LastPass did have some issues with the way they were doing stuff, but generally plugins should be able to... It's kind of one of those, if a user's got a plugin on their browser, they're trusted to be able to kind of do a bit more, so they generally do whatever they want. Which raises the question of, can you trust plugins? Because we all know what happened to one of them recently where it did some nasty things, I think it was. Was it one of the adblock ones? Or? Yeah, JSON View, that was it, yeah. That was...
Some of the developer tools, just Chrome web developer toolbars, and it had a load of ads it was injecting as well.
There's been quite a lot of cases of things being injected.
Yeah.
Mike West is the developer at Google. He's the one who sort of works on the content security policy. He specifies it. And he's sort of taken the view that the plugins are very much the choice of the user, and the user has ultimate control. So there's nothing you, as a local website, can do to stop that. As long as there are no plugins out there exploiting it, and there's quite a lot of them. Google about 1,000 of them recently because they all had a common experience.
Yes, sir. Yes.
Not super relevant, but where you put the thing in the console log, how do you get the font big and red?
Oh, the code will be when you look. If the code's on GitHub, it's like you can use some special formatting to be able to set it. Yeah, I get that quite a lot, but it's all in the repo. How do I do console colors? Can I make it flash and sparkle? Probably. Any other questions? Yeah. That's one. Yeah, strict dynamic. Yes.
Not as we necessarily answer, but this is all web-based. Even we got the same problem with emails. Because I heard about the exploit where somebody loaded in CSS in an email, blatantly rewrote an email. Is there any talk about CSPs? Necessarily work?
I haven't worked with emails in a long time. I mean, it's one of those. Do you still write emails with tables? Is that still a thing? Yeah. Okay. I mean, for example, for the longest time, Outlook used Microsoft Word's rendering engine. Still using it? Okay. Despite the, okay, yeah. I mean, Internet Explorer wasn't great at the time, but I'm like, you've got a browser rendering engine. Why are you using an Office program? So I wouldn't hold out any hope for emails. There are far too many clients, far too many. If you're using a web-based one for something like Google, for example, Gmail, they might do something. I know that they only like inline scripts, for example, so you have parsing engines to pull stuff out and put it in the right place. But I really wouldn't hold out any hope for emails, I'm afraid. it's a dark, dark time when you're working with emails. Was it Kat's talk last week about coding like it's 1995? Emails. It feels very much like that. I haven't written them in like 4 years, but you know, it felt like that at the time, and I'm sad to see that nothing's changed, I'm afraid. Yeah. Any final questions? Cool, thank you very much. Cheers.